All right, class, let's see about the graphs of the other trigonometric functions. So I'm starting with the graphs of secant and cosecant. And the reason for it is because they are the reciprocals of sine and cosine. And it turns out, since we've just gone through section 6.1, that will come in very much in handy anytime you draw the graph of the secant or the cosecant, because all you're really going to do is graph sine and cosine. So let me show you. So if I want to draw the graph of the cosecant function, right, that's the reciprocal of sine, let's draw the sine function. So we already know that the sine function is periodic. I'm going to draw it in pencil with a period of 2 pi, and from 0 to 2 pi, and then I'm going to draw the other halfway through and halfway through. Pi over 2, 3 pi over 2, and so on, okay? And then, of course, I can repeat the same thing. That's 4 pi right here. Cut it in 4 equal parts again, 3 pi. So again, the first cycle shall be very well labeled, but then after that, you don't have to label everything. And then, sure enough, the graph of sine goes as high as 1 and as low as -1. Okay, what does the sine look like? Goes up to 1, first quadrant, down to 0, back down to -1, back up at 0. So this is one loop of the sine function, just as we did. I'm going to draw a second one for you. Up at 1, down at 0, -1, back up at 0. So a second loop. And sure enough, of course, I can do the same thing on the negative side. Down to -2. Up at 1, down at 0, back at 0. Boom. Copy and paste over and over again. Okay. So what happens to the cosecant? It's simply the reciprocal. In other words, what? What's the reciprocal of 1? It's going to be 1. Down here, the sine value is about a half. What's the reciprocal of half? Is 2. This one's a half. What's the reciprocal of a half? It's 2. So the smaller the y values, the larger are the values of their reciprocals. What happens here when the sine value is equal to 0? What's 1 divided by 0? In other words, what's the reciprocal of 0? Well, hopefully by now you've gotten used to it very much that you cannot divide by 0. So when the sine function is equal to 0, the cosecant is undefined. So there you go. So that's exactly what we will do. We'll draw these beautiful vertical asymptotes anytime the sine function is equal to 0, because there's no reciprocal of 0. So the cosecant function is going to be undefined. Comes as low as 1 and then back up, as high as -1, then back down. So there you have it. That's the graph of the cosecant. All I have to do, again, is draw the sine function, right? Make a vertical asymptote anytime the sine function is equal to 0, and then just draw these little u's up and down on it. Okay, so I first wanted to, in fact, draw this function so we can tell what the domain and what its range is. So as you very well see, the graph doesn't stretch all the way left and right. What does the graph do? It skips every time over these x values. So it looks like a rational function, right? It has vertical, and it is a rational function. It's a ratio. So it skips over every time the sine is equal to 0. So when does sine equal to 0? At pi, 2 pi, 3 pi, 4 pi. So clearly, it's all real numbers except for what? Some kind of k pi multiple, any multiple of pi, 0 pi, 1 pi, 2 pi, 3 pi, and so on, where k is any integer. Or you can write it n pi if you want. Yeah, so this is gonna, as soon as we'll start also solving trigonometric equations, you'll see this k pi or n pi. It doesn't matter. Every textbook uses either a k or an n. It's an integer. That's all that matters. Okay, what is the range? As you see, the range is the reciprocal of a number between -1 and 1. So it's going to be more than 1 or less than -1. So the range of this graph goes from -infinity up to -1. So -infinity up to -1. Then what does it do? Jumps and starts back up at 1 to infinity. So these are the values that you will only get out of a cosecant, right? A number more than 1 or less than -1. Okay, so that's the graph of a cosecant. By the way, what would be one complete cycle? Well, it's you drawing one complete cycle of a sine function, yes, and then one loop above and one loop below, basically that, right? After that, these are repeating, yes, one above, one below, one above, one below. So you have to do one of each, okay? All right, secant, the same way as the reciprocal of cosine. So now we got the gist. All I'm going to do is draw a cosine function up to 2 pi, halfway is pi over 2, halfway is 3 pi over 2. The cosine function goes as high as 1 and as low as -1, and then I can definitely copy this again. Again, I'm just kind of gauging it to make sure it's the same distance. Keep your units consistent, please. Okay. Right, what does the cosine look like? Cosine actually starts at 1, goes to 0, -1, back up at 0, back up at 1, right? That's one loop of the cosine function, which is true. Okay, do the same thing, 0, -1, 0, back to +1, a second loop. The same thing. Look at that. And you can keep on going, right, on and on and on. So, same way. Secant, again, looks like a rational function. Why? It's a ratio between 1 and a cosine value. So what happens? Anytime the cosine is equal to 0, 1 divided by 0 is undefined. So I'm going to simply draw myself a vertical tangent line, right? A vertical asymptote anywhere the cosine was equal to 0. And then just draw your u's on top of that. So same as the cosecant lives on top of the sine function, the secant lives on top of a cosine function. So there's plenty of these, well, they look like u's, okay? Up and down, just a little shift. Okay, so sure enough, what would a complete cycle of this cosecant, of this secant look like? The thing is, of course, it's much prettier to draw one u up and one u down, but then it looks like a little bit of a shifty cosine function, and you're not going to think about that. So you will draw yourself a cosine loop, yes, and then you will draw yourself the secant on top of that. So as you see, that is definitely one complete cycle, right? It has one complete down loop and one complete top loop with that. What's the domain? I'm going to write the range first because it's the easier one. So the range, same as the cosecant function, it goes from -infinity up to -1, and then jumps over and picks again from 1 up to infinity. But what's the domain? As you see, we're skipping over values. Which values are we skipping over? Pi over 2, 3 pi over 2. That's, by the way, 5 pi over 2. 7 pi over 2. So you might notice -1 pi over 2, -3 pi over 2. So as you might notice that we are skipping over every odd, right? Not 2 pi over 2, because 2 pi over 2, that's pi, yes? So 1, 3, 5, 7, all the odds. So this is how you will write, I said I'm using K's. That's how you write an odd number. 2 times the number plus 1. So that way you really will get an odd, because 2 times k is an even plus 1 is an odd, where k is any integer. So that's how you write any odd number. And you can pick, right? Let's say k is 0. Then what do you get? 1 pi over 2. Let's say k is 1. So 2 times 1 plus 1, that's 3 pi over 2. Let's say k is 2. That's 2 times 2 plus 1, that's 5 pi over 2. So it works perfectly. Okay. All right. So that being said, now let's sketch one complete cycle of 3 secant of 1/2 x. Great. Secant is the reciprocal of what? Cosine, yes? So that's all I want you to draw, a 3 cosine of 1/2 x. Okay, so let's get ready. What's the amplitude of cosine? Is 3. What am I messing with? I'm messing with your period. Okay, so 2 pi divided by 1/2, by the way, that's 4 pi. Remember that what this 1/2 times x is then multiply all the x values by 2. So in fact, your period will be from 0 to 4 pi. Halfway through is 2 pi. Halfway through is pi. So remember, you still cut it into 4 equal parts. Just 3 pi. What is the amplitude? 3. Okay, so instead of writing 1, we're just going to write 3. And we're going to draw ourselves a cosine in between. So cosine starts up. I'm just going to say a 1, because it really doesn't matter what's there. At the top, through 0, bottom, through 1. Okay, what do? I'm going to draw myself a vertical asymptote anywhere I'm crossing through 0. And then what do I draw? Boom. A nice loop at the top. So there you go. There's my graph. This is it. One complete cycle. One complete cycle at the top. One complete cycle at the bottom. So again, these are things, this is not the amplitude really. A secant function doesn't have an amplitude. Let me write this back here. A secant or a cosecant function don't have an amplitude. Why? Because there's no highest value, right? From the middle line to the highest point. There's no, it goes to infinity, yes? So there is no amplitude. But there's definitely a period, and the period, very important, of cosecant is the same as the period of sine, and the period of secant is the same as the period of cosine, which is 2 pi. So that's the period. Okay. So again, we won't write an amplitude for either one because there's no highest value. Okay. But of course, I did that to myself, because I was concerned about cosine, right? All I'm doing is drawing a cosine function and then just building on top of that. So there it is, okay? So I might be asking you on a test, draw one complete cycle of, and say what the period is. And the period is definitely 4 pi, right? Why? Because that was the period what got for its cosine, right? So you drew one complete cycle from here to there. In this case, there's no phase shift, yes, and there's no vertical shift. Okay. This one will have a phase shift. So what am I going to do? To draw the cosecant, I'm going to draw a sine function, yes? So telling myself about the sine function, I'm going to draw the amplitude's 1. The period is 2 pi divided by 2, right? The number multiplied to x. And by the way, the phase shift is not pi, because this pi is not added to x, it's added to 2x. So what do I have to do? Okay. So I'm factoring out that 2, and now I know that the phase shift is negative pi over 2. Okay. So let's go back to what we've practiced. I'm going to draw myself a sine that starts at negative pi over 2 and is in fact pi units long. So all I'm going to do is just go as far as pi over 2, right? So that's pi units long. So from negative pi over 2 plus pi, right? So negative 1/2 plus 1 is positive 1/2. So that's where it starts, that's where it ends. So as always, I need to cut my halfways. Halfway 0, pi over 4, negative pi over 4. Okay. What's the amplitude's 1 to negative 1, okay? And I'm going to draw myself a sign. But remember, this is a flipped sign, okay? So, in other words, what? When I'm drawing my sine function, this is a regular sine function, yes? It goes up and down, yes? However, this time, because I have to flip it, I will first go down to negative 1, back up at 0, back up at 1, back down to 0. Okay, so here is my nicely flipped sine wave. Okay, what do I do with that? Wherever I see 0, that the sign is crossing through 0, I'm going to make myself a vertical asymptote. And I'm going to draw right on top of it. So this is the graph of that cosecant function right here. So done. Okay. All right, so nothing new really. All it goes back to, if it's a secant, you draw yourself a cosine and then just build on top of it. First, again, draw your vertical asymptotes through the crossing points, and then put the graph up and down. And that's it. So we're going to continue with the graphs of tangent and cotangent on the next video.